All right, so the first thing that we're going to talk about today is first we're just going to go over memory and storage devices in general, and then we'll talk some specifics about the SD card, shield, and library, and SD cards themselves. Um, so memory devices, what we mean by that is electronic devices that can store information for use in electronic hardware, and that you can then do digital, mathematical or logical operations upon, i.e. we can do calculations with it. And this can be both what is called volatile and non-volatile, i.e. do you lose the information if you lose power, or is it something like permanent storage? So different types of examples that you may run into are something called EEPROM, RAM, like your computer uses, or that the Arduino uses as its like programming memory. That's a memory device. And then flash memory, like an SD card, or an older format called a compact flash card. Those are all different types of memory devices, right? They all can store information and then do calculations on it. But on a basic level, these are all made up of little individual logical pieces put together. And the individual elements are sometimes are called logic gates if they do a logical operation, and you can combine these to build certain things called other things called latches or flip-flops. So a latch is something that would stay in the state, so you would like turn it on and it would stay on. And a flip-flop is something that you can send a signal to change it from a true to a false, right? And these are basically how you build up a whole bunch of these things together, and this combining these is what gives you, your memory storage. So the logic gates are similar to the logic operations that we've talked about in programming. You have and, or, not, NAND, and NOR are the most common ones. And these work exactly like the programming statements, except the inputs are actual electronic signals. These are actual pieces of physical hardware. So if I have an input to an AND gate, I have a positive 5 volts and a positive 5 volt signal going into it. The output will be a positive 5 volts. But if I have a positive 5 volts and a 0 volts in, it'll be 0. So they just work exactly like that. And then if you combine these, there are a number of different types. The D flip-flop is the most common, but these are just combinations of these logical circuits that you build up to create pieces that go into memory. So as I said, there are two types of memory devices, and what you call, the term you use to refer to these is either volatile or non-volatile. A volatile memory is something that requires you to keep power supplied to it for it to maintain its information. And the most common example is your RAM. So if you turn off the power and you turn it back on, everything goes back to its initial set values. If you start your computer back up, your RAM goes to its initial values. Again, if you cycle power to the Arduino, because all of your variables are stored in RAM, they all go back to their initial value. The other type is called non-volatile, and that's stuff that keeps the information even if you lose power. So when you turn it back on, it stays at whatever it was before you lost power. So like the flash memory that your program is stored on the Arduino is stored in non-volatile memory. The SD cards that we're going to use is non-volatile memory. Your hard drive is a type of a non-volatile storage device. Because all of these things have at least some sort of permanent storage, unless they get overwritten, you can read them off after you cycle power. So one type is what's called ROM, which is read-only memory, as in a CD-ROM is a compact disc read-only memory. For a regular CD, you can't write to it, you can only read from it. And so traditionally this means that you can only read from it after it has initially been written. But EEPROM, which we mentioned was a type of storage device, is actually something that you can write to and then read from. But it's very slow, and it's sort of an outdated form of memory storage. The older BalloonSat, which was the piece of hardware prior to the Megasat, that had EEPROM on it. And as I think we've mentioned, there is a small EEPROM on the Arduino board, but it's not really we don't really go over how to use it, and it's very small and it's slow. Another thing about them is they have a limited number of read and write cycles. So eventually, basically, the electronics give out and you won't be able to overwrite new data, which makes it, this is usually in thousands or millions of read-write cycles, but if it's a piece of equipment that you're going to want to be using for a long time, that's something you would want to consider. But if it's something that you're not going to change very often, so an example would be like the basic firmware that sort of runs the hardware on a piece of device, you could store it on that. A lookup table is just something that if I give you a certain number, I get another, I look up another number from it. So those are the sort of things that would probably be fixed and not changed very often. So in that case, you're not really worried about the read and write cycles. So another type is flash memory, and that's a much more modern type of memory. It is something that's easy to erase and easy to be reprogrammed. And most importantly, you can build it in a larger number of memory spaces, i.e. you can store a lot more information on it. So EEPROMs are often, on the order of kilobytes of storage, whereas, flash memory is what you use for SD cards and solid state hard drive. And, nowadays you can easily get those up into the terabyte or gigabyte, which is millions and billions of times larger than what you can store in an EEPROM. And most importantly, they're also faster than an EEPROM. So like we've mentioned before, RAM is memory. That's what the M stands for, but it is volatile memory. So that's where you keep variables and information that you're actively working with. And one of the advantages of that is they're relatively fast. So if there's something you don't need to store, you can just keep it in RAM and you can do calculations with it very quickly. And usually, if you're actually going to be operating on stuff, you have to read variables into off of the volatile storage medium into RAM before you can actually do anything with it. And like I said, that is where you keep the information you're actively manipulating at a particular time. That is what your processor is going to be talking to and getting values from. Hard drives are what normally would be your large storage capacity devices. They are, magnetic devices, and especially in the past, before you could build large, reliable flash memory devices for cheap, you needed to use hard drives. So the data is stored in, chunks that are called blocks. And how it actually works is you have a disk that has little magnetic material on it, and there is a physical reader called a head that moves across this disk as it's spinning, and you read, basically, is the magnetic field at that one little spot pointing up, or is it pointing down? And that's what gives you your zeros and ones. Because it's, a permanent magnet that you have written, you don't have to maintain power. So if I turn it off, the magnetic fields on the disk stay the way they were. And even these days, that is, your primary storage device for computers, especially if you need a lot of storage space. But what we're primarily going to be using here is what's called an SD card. So they are small, non-volatile memory devices. They, like I said, they use flash memory to store large quantities of data. And you can get very large storage capacity in a very small form factor. We'll take a look at what the actual SD cards look like a little bit later. And pretty much, especially these days, this is your primary storage for cameras. I know a lot of people, a lot of phones have an extra SD card slot, so you can have increased storage space. And many of your actual laptops and PCs will often have an SD card slot so that you can put one in, put an SD card in there either to read information off of it or to use it for extra storage. So this is what the SD cards look like. So there's actually a number of different sizes. So the outline here, the largest one, is your standard SD cards. And then the next size down that you don't see very often is called a mini SD. And then the very small size is called a micro SD. And you can see, if you look on one side of these, you will have a number of different pins. So these are the contacts that actually that either in your computer or on your device, that is how you're electronically contacting with it. And if I switch over briefly here to the camera, I can bring up the SD cards. So everyone should be seeing two cards here. So this right here is the standard SD card size, and this little one right here is a micro SD card. And you can see basically roughly the micro SD card is roughly the size of my fingernail, and the full size SD card is a little bit bigger than that. All right. So like I said, you have these three sizes, but really most commonly you just see the full size SD card and the micro SD card. And these days often you'll just see the micro SD cards and you'll have like an adapter for the SD card, because most often your slots on your computers are the full size. So the SD cards have they're formatted a certain way. The way that's formatted is called the file system. So this is what basically tells a device that's reading it how files are stored, how does it know where the different files are located on the card. And depending on the file system, you may have a maximum partition size. So usually you only have a single partition. A partition is basically just when you have a single physical memory device broken up into multiple different storage sections. So you may have on a computer a hard drive that has its hard drive broken into two different spots, two different sections. So like your C drive will be your Windows partition, and you'll have like a D drive that is all of your data. But you know, those may be physically on the same physical hard drive, but they're just partitioned separately. So one of the storage devices, or not storage devices, one of the file systems is called FAT16. That stands for File Allocation Table, and then the 16 means that it uses 16 bits of addressing. But what that means is, because you only have so many addresses in those 16 bits, you are limited to a certain number of storage locations, and actually 16 bytes of address space, not bits. Because you only have so many locations, that means on that storage, you only have 2 gigs of possible storage. But if I increase that by just making the addresses actually longer, I can allow for more possible locations, which increases the amount of storage available. So what you'll see often is FAT, which is File Allocation Table again, followed by a number. So you can increase that up to 32, which gives you up to 4 gigs, or 64, which will give you up to 2 terabytes, which is generally much larger, or which is larger than most memory devices you'll find these days. But there was a point in time when people would have said there's no way you'll ever need more than 2 gigs, but we found bigger and bigger amounts of information. You can make, high definition video. All of these things start to take up more and more space. But sort of the key takeaway here to remember is this 2 gigabit limit on the FAT16 file system, because at least on the library we're going to initially work with, it's going to assume a FAT16 or FAT16, which means even though our SD card may be 64 gigs, 128 gigs, only the software will only be able to deal with 2 gigs of that space. So that's something you want to keep in mind with what library you're using, what file system is it compatible with, how much of the actual storage space can you access. And that is it for our first lecture.